Thank you. And I say favorite because probably physics is what you've dropped probably in your, after your 12th. I don't think you got in touch with physics for a very long period of time. But as you know that it is essential for your entrances, and gravity is a very big topic. So obviously we will be able to just, touch the tip of the iceberg. But at the same time, it is one of the most important topics as far as entrances go. And by the end of the lecture, I'm sure you people would realize that why it is important, because I have picked up last 4-5 years papers of your common entrance exams of biochemistry, and you would see that every year there is a question that has appeared. Like in 2018, there's there 2017, 2016. Then I have picked up a question from JAM 2020. So every year there is a question on gravity, and it is one of the most easiest subjects if you understand it well. At the same time, it becomes one of the most difficult subjects if you do not have enough practice and if you are not interested, both the things. So please make sure that because of your lack in the subject, you don't lose marks. Having said that, first topic that we want to talk about is acceleration due to gravity, which everybody knows that acceleration due to gravity G, and G is 9.8 meters per second square. Everybody is aware of that. Now, Newton was the first person who was given laws related to gravity, and he said that every body in the universe attracts every other body with a force which is directly proportional. So supposing if you have two bodies which are spread like this with mass m1, this with mass m2, gravitational force is a central force, all right, and the distance between them is r. Then F is directly proportional to the product of their mass, that is m1, m2, if it is the same mass, and inversely proportional to the square of the distance. And when you remove the proportionality constant, you get gravitational constant, that is G, which is universal gravitational constant. The value of G is 6.67 into 10 raised to minus 89 per centimeter square, or it is 6.67 into 10 raised to minus 11. Now, most of the times आपके entrance exam में ये values constants की दी होंगी, but once in a while, जैसे ये value वो लोग नहीं देते हैं, they don't give this value. So in that case, you will need to remember that G is 9.8 meters per second square. All right. At the same time, the force is always attractive in nature. जैसे इलेक्ट्रॉन और प्रोटॉन होते हैं तो वो अट्रैक्ट करते हैं, दो इलेक्ट्रॉन्स होते हैं तो दे रिपेल, but that is not the case in gravity. It is always attractive in nature, and you need to remember that. So the first formula, that is gravitational force, is Gm1 m2 by r square. If the masses are same, then it becomes Gm square by r square. Now, there are mainly 4 types of fundamental forces. Gravitational force, that is due to gravity, all right, or gravitational force that exists on every body when you are high above. Then you have is weak force. The origin of weak force is leptons, and so basically subatomic particles. Then you have is electromagnetic force. The very word suggests that a current carrying wire is there, it will produce magnetic field, and uski wajah se jo force aata hai, that force is, I am switching in Hindi in between because I have been told that there's a mixed crowd and I don't want people not to understand. So that is the reason. So you have gravitational force, then you have weak force, then you have electromagnetic force, and the strongest force is the nuclear force. So as you have these 4, this is the weakest among all forces. and this is the strongest. So from weakest to strongest is like this. From strongest to weakest, you go in this direction. All right. Nuclear force is, or the strong force is the strongest, whereas the gravitational force is the weakest force which is existing in the universe. And these are known as four basic fundamental forces. All right. So this is just an idea of where do we stand with respect to gravity. Now, we know that acceleration is force per unit mass. Here, this acceleration we're talking about is acceleration due to gravity. The equation of force we just said is gm by r square, and divide by m, so m and m will get cancelled. So you get gravity or acceleration due to gravity is gm by r square, where g is the gravitational constant, m is the mass of the earth, and r is the radius of the earth. All right, and the value is found out to be 9.8 meters per second square, or you get 980 centimeter per second square. Another very important thing in physics में सबसे important जब आप numericals या आप MCQs attempt कर रहे हैं, तो you have to make sure कि हर एक चीज एक ही system of unit में है. मास अगर ग्राम्स में है तो फिर ये सेंटीमीटर में ही होना चाहिए. अगर ये आप केजी में लेते हो और ये सेंटीमीटर में लेते हो तो आपके आंसर्स यू गेट रॉन्ग आंसर्स. सो प्लीज मेक श्योर दैट यू कीप इन माइंड टू कन्वर्ट centimeters to meters, grams to kilograms. Alright, these are SI units, standard units. And it is very important that you have your answers in a single system of units. So equation of force is gm1 m2 by r square. Equation of gravity is gm by r square, where equation of force is applicable to any bodies. And when we talk about gravity, here we are talking about gravitational force exerted on Earth. So that is why we have taken mass of Earth, we have taken the radius of Earth. So it is like this is the body and this is the Earth, and we are talking about this. Now this distance compared to the radius of Earth is negligible, so you just take r as the equation. I am hoping that all of you are noting down at least the equations, because end of the lecture I would expect you to give me answers. All right. Now, what is the effect of height, that is altitude? As if you're standing on a mountain or you are moving out, all right, or you climb height. So the acceleration due to gravity varies. It doesn't remain constant, it changes. And because it changes its value, this is the new acceleration due to gravity at a given height. This is on the surface of the Earth. And we can see that as you move up, your acceleration due to gravity decreases, where h is the height from the surface of Earth, r is the radius, and g is the original gravity or the new gravity. I mean, g dash is the new gravity. So as you climb up a tall mountain or as you move up in space, your gravity goes on decreasing. All right. And of course, everybody is aware that there is only a range till which gravity exists. Now, there is a derivation to this. Here, I hope you can see that when I'm taking the distance between the two bodies, the body is here. I have not taken it as r plus h because I have considered ki h ki value r is 64,000 kilometers. So if h is say 3 meters or 8 meters, or even if it is 1 kilometer, compared to 64,000 kilometers, it is negligible. उसका कोई वैल्यू नहीं रहता है. बट मान लीजिए कि ग्रेविटी उस हाइट पे हम चेक कर रहे हैं, से एट 15 किलोमीटर्स और मे बी से 100 किलोमीटर्स, तो उसको हम निग्लेक्ट नहीं कर सकते. देन योर इक्वेशन बिकम्स g डैश इज g upon 1 plus h by re the whole square. So please read the question carefully. As far as I have seen the papers for your entrances, they always give h as negligible, where h is much lesser than r. तो आपके उसमें 99% ये फॉर्मूला यूज नहीं होता है. बट इन केस अगर h की वैल्यू कंपेरेबल टू रेडियस ऑफ अर्थ है, तो यू आर टू यूज दिस फॉर्मूला where g dash is. But I would recommend strongly कि आप ये फॉर्मूला याद रखिए, that g dash is g into 1 minus 2h by r, where h is the height to which you are going, say 5 meters or 8 meters or whatever value that you have in the question. But mostly questions ऐसे आते हैं कि what is the gravity at height of half the radius of earth, or what is the gravity when you double the height and reduce the radius to 1/4. So it is just mathematical manipulation से आपको आंसर मिल जाता है most of the times. So it is not just simple formulae, but वो formulae की application भी you are expected to apply. All right. Anybody has any question? Do you have the option to unmute yourself and speak? Sir? Children, do you have the option of unmuting yourself and speaking, or no? You've all been muted.
Yes, ma'am, we have.
Okay. So please, in case आपको अगर कहीं नहीं समझ आता है, please feel free to question. The idea is that you get the best of what is required. And I hope if anybody is not following English or you're not comfortable with English, you want me to speak in Gujarati, please tell me that. I can do that as well. All right? Because there are benefits of online, but at the same time, there are also disadvantages where I cannot see any of your faces. So I have no clue whether it is going in your head or whether it is going above your head. ટપ્પા પડે છે કે બાઉન્સર જાય છે એ મેડમને નહીં ખબર પડે. સો ક્યાંય અટકો તો પ્લીઝ સ્પીક ઓર પ્લીઝ આસ્ક કે મેડમ આ કેવી રીતે, કે મેડમ આ તમે શું કહેવા માંગો છો, what are you trying to say. All right. So this is when you move up the surface of earth, when you're moving at height. In the same way, if you move inside the earth, mines the under, if you move towards the center of the earth, that is depth of the earth, then in that case, your equation of new gravity would be equal to g is equal to g dash into 1 minus x by r, where x is the depth in which you are going. Say, are you going 1 kilometer inside the surface of the earth, 2 kilometer inside the surface of the earth? Again here, most of the times you'll be using this equation. Once in a while, when, you do not have a total where h is not negligible, then the new gravity would be g into 1 plus h by re. So that is also there that you can talk in terms of, but otherwise x is the depth. Again, as I was looking at your papers, there is hardly anything which is based on where the depth is or the other formula is used. So I would expect you to remember this, where G is the new gravity. All right, as we go below the surface of the earth. Again, as you can see here, whether you go above the surface of the earth, if I consider this to be the surface of the earth, whether I go above or whether I go below, below means towards the center of the earth. In both the cases, gravity will decrease. And please remember that whether you go below the surface of the earth or you go above the surface of the earth, in both cases, the gravity will reduce, or so maximum is at the surface. Anya gravity is maximum. Another very common question in your entrance is where is gravity maximum and where is it minimum? With respect to Earth, gravity is maximum at poles and it is minimum on equators. Alright? Equator ma gravity સૌથી ઓછી હોય અને poles ઉપર gravity maximum હોય. So that's another repeated question that you may have in your entrances. So please keep that in mind as well. Now, if you look at a graph of variation in the value of acceleration due to gravity, as you can see, even graphically, this is the surface of the earth. Ghanivar, even graph are asked in MCQ. Alright, so you can see that below the surface, ઘટતી જાય છે, towards the center સાવ zero થઈ જાય છે. Same way, above the surface એ ઘટતી જાય છે. This is the radius. પછી આ 2r, એટલે એનાથી વધારે, આ 3r and so on and so forth. So distance from the center of the earth. In both the cases, the gravity goes on decreasing. As you can see from the graph that it is maximum on the surface of the earth. Alright? And please remember these graphs and even the shape. Because 4 option હોય એમાંથી એવું હશે કે above the surface, as you can see, is exponential decrease. સીધું નથી ઘટતું. It's a curve. Whereas below the surface, it's a straight line graph. So even the shape of the graph, you should or you must remember. Alright? Are we comfortable with the pace? Can I move ahead, children? Boys or girls?
Yes, ma'am.
Yes, ma'am.
Great, great.
Yes, ma'am.
Thank you. Now, we've done તમારા મોસ્ટલી જે બી ક્વેશ્ચન્સ ગ્રેવિટી રિલેટેડ હોય છે, એક તો હાઇટ, ડેપ્થ એના રિલેટેડ હોય છે અને મોસ્ટ ઓફ ઇક્વેશન્સ હોય છે ગ્રેવિટેશનલ મોશન રિલેટેડ. ધેટ ઇઝ મોશન ડ્યુ ટુ ગ્રેવિટી. Now, I hope everybody knows, or it's just a recap. Linear motion એટલે તમે આમ સીધા જતા હો એને linear કહેવાય. Gravitational motion એટલે તમે under the influence of gravity move કરતા હો એને gravitational motion કહેવાય. So this is my final velocity. This is my initial velocity. This is my acceleration and this is my time. So this same equation, when I write, it is V is equal to U plus or minus GT. Now, why do I have plus or minus? Because if you are coming in this direction, alright, you take gravity as positive. If you are throwing a ball up or you are jumping or something like that, then you are going against gravity and then you take gravity as minus G. And that is why in the equation I have written plus or minus G, because depending upon the situation, okay, whether you are going with gravity or whether you are going, supposing you throw a ball down. So throwing a ball down is gravity will be positive. But that same ball you throw up in the sky, then you take gravity as negative. And so you use, if you are throwing up, you use equation V is equal to U plus GT. Sorry, you use it as V minus GT. And if the ball is coming down, or you throw it from a terrace, then the equation becomes V is equal to U plus GT. And so it is important that we remember that it could be plus or it could be minus depending upon the direction of gravitational force. Now S is equal to ut plus half at square, where S is the displacement, U is initial velocity, T is time, A is acceleration. Now here instead of S, you will write as H. Alright. So H is equal to, see, I have done it here. Here I intentionally left it so that I can say that S ni jagyaye you will use H. Alright. So H is equal to ut plus half gt square, and v square minus u square is equal to 2as. So v square minus u square becomes plus or minus 2gh. Because this is acceleration due to gravity, must that you must remember these equations, because in your entrances most of the questions are based on this formula. So I hope that you are noting it down. All right. Escape velocity. What do we mean by escape velocity? Escape velocity is the minimum velocity with which a body, supposing I am on Earth and I want to go to a place where I do not experience any gravity. I want to escape the gravitational force. All right. So the minimum velocity, not maximum, minimum velocity which a body must be projected so as to enable to overcome the gravitational pull or gravitational force is known as escape velocity. All right. And you can derive that escape velocity is root 2g m by r, where g is gravitational constant, m is the mass of the earth, and r is the radius of the earth. Now, I know that acceleration due to gravity is gm by r square. So I have this gm and r. I do not have a single r here. So I multiply that r here and I will get escape velocity can also be written as root 2gr. I hope that people remember that we did that acceleration due to gravity is this. So in this case, I only have gm by r. So if I multiply this by r and divide this by r, then this becomes r square, and then I can replace it with g. So then the other formula is root 2gr. Alright, again, you are expected to remember the formula. More than often, gravitational constant, mass of Earth, radius of Earth will be given. But acceleration due to gravity will not be given. And escape velocity is what is the minimum velocity that a body requires. Now, from Earth, the minimum velocity that a body requires to move out of the surface of the earth, does anybody have any idea how much it should be? Please remember this, કારણ કે I ઘણી વાર પૂછે છે. It is 11.2 kilometers per second. That means every second we have to cover 11.2 kilometers if we want to escape the earth's gravity. All right, or gravitational pull or Earth's gravitational force. So escape velocity is either root 2gr, and r is the radius of the earth. And if I substitute the mass of the earth, if I substitute the radius of the earth, and if I substitute the acceleration due to gravity, then answer I get is 11.2 kilometers per second square. Please remember that. So, another thing is orbital velocity. What do we mean by orbital velocity? Now, orbital velocity is, I am sure now with so much of exposure of Chandrayaan 2, and we had this, Chandrayaan 1, and we had Mission Mangal with the films that we have and all of that. We are all aware that India is one of the most leading countries to send satellites to space. And once you send a satellite in space, તમે એક વખત satellite ઉપર મોકલો, then you have to make sure that is satellite Earthના orbitમાં ફરે, or it has to revolve around Earth's orbit, right? And then all the things that you do today, like most of your internet, your mobiles, the live matches that you see, the signals that are there, that is all through satellite communication, telecommunication mostly, or all the TV channels that you get and live streaming that you have and all that is through satellites. So orbital velocity is the velocity of a satellite which is required to put the orbit around the Earth, and not necessarily just Earth. Like supposing when we talk of Mission Mangal, or I'm saying it with the film reference because most of you would have seen that, is where we wanted to have capture pictures and have things of mass, and the mission was for that. So you can also have it orbited around that. So if I have a satellite and the velocity that is required for it to move around the Earth's is known as orbital velocity, and orbital velocity is given as VO is equal to root gm upon r plus x, where x is the distance, this is r, and this would be x. Now, many a times, if you launch a satellite very near to the surface of the earth, તમે બહુ દૂર ના launch કર્યું હોય, નજીક કર્યું હોય, તો then r is much greater than x. So this equation then becomes root gm by r. So it depends whether your satellite that you have launched is very far, or whether you've launched a satellite which is very near to the surface of the earth. Alright? અને જો બહુ નજીક હોય, if it is very near, then you neglect x. But if you have launched a satellite which is far off, then you cannot neglect x, and then you'll have to use this formula. Now, if I want to use the equation in terms of gravity, I hope everybody will agree. Again, here it is gm by r. So, if I multiply by r and if I divide by r, then this will be gm by r square, and that will be equal to g. So, orbital velocity can also be given as root gr. Very frequently asked question, ratio of orbital to escape velocity, or ratio of escape velocity to orbital velocity. So I hope you remember that in the previous slide we saw that escape velocity is root 2 gr and orbital velocity is root gr. So if I take the ratio of this, all right, you could have it in terms of root gr into root gr. Your answer would be root gr. Don't write answer as 2. Then that will be wrong answer. That's the most common mistake. Yes, you can say twice. Escape velocity can be twice as the orbital velocity at any given point in time. But look at what the options, आपको जो options दिए हैं, उसको आप ठीक से देखिए and then figure out what answer you want to write. So this is another important formula जिसके ऊपर numericals आ सकते हैं, which is orbital velocity. And I'm repeating, it is the velocity required by a satellite to put itself around Earth's orbit. The very word suggests geo and stationary.
Hello, ma'am.
Yes, ma'am. Now,
can you please repeat the ratio wala part?
Just substitute the value of C. VE is root 2 GR and VO is root GR. So just cancel it and you'll get your answer. So orbital velocity is half the escape velocity, or if the options are given in terms of GR, then you can, this root 2 GR can also be written as root GR into root GR. So I'm saying just have a look at the options that are available.
Okay, ma'am.
Yeah? All right. Now, a satellite which is at rest or appears, actually it is not at rest, but it looks as if it is at rest, is called a geostationary satellite. Geo is Earth, stationary means at rest. So, a satellite which appears to be at rest from the radius of the Earth is known as a geostationary satellite. Now, a satellite will appear stationary if it revolves around the Earth from west to east. All right, in an orbit coplanar with equatorial plane and at a height about 36,000 kilometers from the surface of the Earth. Now, this is known as a synchronous satellite, all right, or simply a stationary. Synchronous means in sync with. That is what is known as synchronous. And a geostationary satellite. Why do you need a geostationary satellite? What will be the time period of a geostationary satellite? If it has to appear, time period क्या होगा geostationary satellite का? Can anybody tell me? What should be the time period of a geostationary satellite? For a day, if we are talking 24 hours, axis of the rotation of the Earth on its own self is 24 hours. If we are saying synchronous for the whole year, then it has to be 364 point some days. And the main purpose of satellites to be geostationary is so that you don't need different satellites. For पूरे साल उसमें से you can click pictures, you can get information, you can do all that. Or what are the purpose of satellite? Satellite का main purpose क्या होता है? Weather forecast, spying on different countries. Pokhran, I don't know how many of you seen the film Pokhran. So in that you had where all the Americans keep spying on all different countries through their satellite and all. So one is weather forecast, spying, then finding out mining areas. All right, and nowadays all telecommunication, there's live matches, OTT platforms, everything is working on satellites. So now, recent times, we also have a lot of worry of e-waste and we also have a worry of traffic in space. तो अभी हमारे पास स्पेस में पार्किंग की जगह नहीं है, तो देन दे हैव नॉन सिंक्रोनाइज सैटेलाइट. फिर उसमें उन लोगों को कॉन्स्टेलेशन बनाना पड़ता है. सपोजिंग इफ दिस इज अर्थ, तो 3 सैटेलाइट्स लगाएंगे एक ही ऑर्बिट में. ये सैटेलाइट 4 महीने काम करेगा, फिर शट हो जाएगा. फिर ये सैटेलाइट 4 महीने काम करेगा, जहां से वो अर्थ का इंफॉर्मेशन फ्रॉम वट एवर पार्ट दैट यू वांट. Then this. So they have constellations of satellite. And the main purpose of geostationary satellite is that it can give you information around the year. Weightlessness. The state of weightlessness can be observed in when a body is obviously falling freely. Can anybody give me an example of weightlessness or the state of weightlessness in our day-to-day lives? Where do you feel that? All youngsters should be knowing. Any one of you?
Ma'am, while inside of swimming pool, I think.
inside of swimming pool, it is more related to buoyant force, beta. So we not in there also you can. It's not a wrong example. It's absolutely a right example. And so you're saying with respect to gravity.
In lift,
Very good. In lift, if suddenly the lift falls down, all right, when there is a sudden fall, then there is state of weightlessness. The easiest example is bungee jumping. When you jump from like for quite some time, you have a free fall, and there you have weightlessness, or a body does not experience its weight. So that is weightlessness. When a satellite revolves in its orbit, that surrounding atmosphere does not offer any frictional force. Then, like you might have seen certain videos where people in space keep floating, where the liquids float and people are floating, because that is where they experience the gravitational force is zero. So they experience weightlessness. And when the bodies are at null points in outer space, that's zero gravity. So these are all where you experience weightlessness. Now, this is another. Kepler was the person who was given 3 different laws. But in your syllabus, it's only the 3rd law, and it is the most important law. First law just talks about that all planets revolve around sun in an elliptical orbit. That is the first law of Kepler. All right. And when it is here, the radius is smaller. When it is here, the distance from that is bigger. So you have an apogee and an apogee. And then the rule or the law talks about average radius. Not 2 different radiuses, not when it is the nearest and not when it is far, but you take an average of that. The second law is, it states that the aerial velocity is constant. That means the area a satellite covers in a given time is always same. So dA by dt, aerial velocity is constant, which is again, you don't have that. The third and the most important is Kepler's law of planetary motion. These are all known as Kepler's law of planetary motion. First law, it moves in an elliptical orbit. Second, aerial velocity of all planets are constant. Third, the square of period of revolution, time period. Time period is, I hope everybody knows, time period is the time required to complete one revolution from here back to this place. So if I start from here and I go back here, the time required is known as the time period. And practically he found out, or with his calculations, theoretical calculations, and then seeing, he found out that the square of the time period of any planet around sun is directly proportional to the cube of its average radius. So t square is directly proportional to r cube, or t square is equal to kr cube, where k is constant. So if I have 2 planets, supposing I want to know, mostly the questions are in this, that 2 planets, or Mars and Jupiter, the average radius of Mars is 3,600 kilometers. The average radius of Jupiter is this. The time period of Mars is any value, 280 days or 180 days. What is the time period of the second? So if I take the ratio of T1 by T2 square, R1 cube by R2 cube, K and K will get cancelled, and I get an equation which says T2 by T1 square is equal to R2 by R1 or T1 by T2, depending upon question में क्या पूछा है. Have they asked the ratio of T1 by T2, or have they asked the ratio of T2 by T1? But the most important thing you must remember is, because in your questions or in your board questions, what they, not board questions, I'm sorry, the entrance exams question, what they ask or what they give is 2 radiuses, the minimum radius and the maximum radius. So don't forget to take the average radius. अगर गलती से उसमें से कोई भी एक रेडियस लेके क्वेश्चन किया तो आंसर 100% गलत आएगा. So please do not make that mistake. All right. And T is the time period. That is the time taken by any planet to take one complete revolution around sun. And T square is proportional to the average distance from the sun. And this law is also known as law of periods or law of time periods. Is everybody clear with this?
Yes, ma'am.
Fantastic. So from your 2017, your biotech paper 2017, question: which of the following is correct order of basic force? Now, fundamental forces are also known as basic forces. And can somebody please tell me what's the correct answer?
Option A.
What do we want? Decreasing strength. Decreasing strength means सबसे strong पहले आएगा, सबसे weak बाद में आएगा. Now again, please remember one thing. When you saw that fundamental, option A is absolutely correct, whoever said the answer. Also, when you're doing MCQ, speed is what matters. So the easiest way is to rule out wrong answers. All right. Now, common sense. As I said, you must remember the starting force and the end force. So gravitational और strong, दो में से एक ही होगा. तो कहीं पे भी एंड और बिगिनिंग, यहाँ स्ट्रॉन्ग से स्टार्ट होता है पर एंड में ग्रेविटी नहीं है, यहाँ एंड ग्रेविटी से होता है बट यहाँ पे स्ट्रॉन्ग नहीं है. So all three other options automatically gets nullified. If this same question was asked in increasing strength, what should have been your answer? Then it should be gravitational force, then weak force, then electromagnetic, and then strong. All right, everybody? Decreasing strength means कम होते जाना, सबसे strong सबसे पहले और सबसे weak force last में. Is everybody clear with this?
Yes, ma'am.
Yes.
Chalo.
Yes, ma'am.
I already said the answer is this. Chalo, now this is something that you will have to tell me. A stone is initially at rest and then is released from height h as measured from Earth's surface. So यहाँ पे stone है, drop it, where gravitational potential energy is mgh. While falling, kinetic energy of the stone same रहेगा, potential energy same रहेगा, total energy same रहेगा या none of the above? What should be the answer? At any given point,
Potential energy.
બેટા પોટેન્શિયલ એનર્જી જેમ જેમ ઈ નીચે આવશે તો એની હાઈટ તો ઓછી થતી જશે, તો ઈ કેવી રીતે સેમ રહેશે? તો ઈ તો તારો આન્સર ખોટો થઈ ગયો. કાઇનેટિક એનર્જી એ પેલા અહીંયા હતું ત્યારે 0 હતી કાઇનેટિક એનર્જી ને, કારણ કે ઈ મૂવ જ નહોતો કરતો, ખાલી પોટેન્શિયલ જ હતી. તો કાઇનેટિક એનર્જી એ સેમ નો રહી શકે, તો આ આન્સર ખોટો થઈ ગયો. ધેટ મીન્સ આ બે માંથી જ હવે કાંઈક હોઈ શકે. When it is at the top, it has potential and 0 kinetic. જ્યારે ઈ નીચે આવે તો કાઇનેટિક વધતી જાય અને પોટેન્શિયલ ઘટતી જાય. જસ્ટ બિફોર ધીસ એની બધી પોટેન્શિયલ કાઇનેટિકમાં કન્વર્ટ થઈ જાય. પણ એટ એની ગિવન પોઈન્ટ ઇન ટાઈમ, please remember law of conservation of energy. Energy can neither be created nor destroyed. It can just be transferred from one form to another. So at any point, the total energy will always be same. All right. When you drop a ball, kinetic can be converted to potential. Potential can be converted to kinetic, but the total energy will always remain conserved or will remain same. This is also, so see, in the same year, you have 2 marks on gravity. Is everybody clear with what I said, guys?
Yes, ma'am.
Yes, ma'am.
Yes, yes.
Great. So the answer is total energy will remain same or remain conserved or remain constant. Chalo, now this you do it and tell me what's the answer. A ball thrown vertically upward. This is from 2016. As you can see, every year one question. A ball thrown vertically upward returns to its starting point in 4 seconds. Initial speed of the ball is. Initial speed એટલે તમે શું ગોતો છો? U ગોતો છો. I've given you a big hint. And no guesswork I want, huh? Work out.
B 9.8 9.8.
Okay. On what basis are you saying 9.8?
मैम वो ग्रेविटी होता है ना, ग्रेविटी के आपने शुरुआत में चला है ना, ग्रेविटी ऊपर बॉल को ऊपर फेंकेंगे तो फिर उसकी एनर्जी स्टैंड में 9.8 ही होगी ना.
બેટા ગુજરાતીમાં બોલ 9.8 તો એક્સેલરેશન ડ્યુ ટુ ગ્રેવિટી આપણે કીધું ને બેટા. અહીંયા તને પૂછ્યું છે શું? સ્પીડ એટલે વેલોસિટી પૂછી દીકરા તને. ગ્રેવિટી આપણે 9.8 મીટર પર સેકન્ડ સ્ક્વેર કીધી, પણ તને એક્સેલરેશન નથી પૂછ્યું. તો શું કરશું અહીંયા આપણે? કયું ઇક્વેશન? You are throwing it upwards. તો મારે ગ્રેવિટી પોઝિટિવ લેવાની કે નેગેટિવ?
Negative.
નેગેટિવ.
नेगेटिव मैम.
Correct. હવે a ball is thrown vertically upward, return to its starting point. એટલે return થઈ જાય તો velocity શું થઈ ગઈ? નીચે આવી જાય પાછો ball. તો એની final velocity શું થઈ ગઈ?
0.
Very good.
0 मैम.
I say U is equal to GT. હવે ગ્રેવિટીની વેલ્યુ આપણને ખબર છે 9.8 છે. જો આ ક્વેશ્ચનમાં નથી દીધી, so they expect you to remember. ટાઈમ કેટલો લઈશું? 4 સેકન્ડ લઈશ કે 2 સેકન્ડ? બોલ ઉપર જાય છે અને નીચે આવે છે. આ બે વસ્તુ કરવામાં it is taking 4 સેકન્ડ. તો ખાલી ઉપર જવામાં કેટલી સેકન્ડ લાગશે?
Ma'am, 2 seconds.
તો what time will I take? 2 seconds. So my gravity is 9.8. My time is 2 seconds. હવે કયો આન્સર શું આવશે? Hmm?
19.6.
Perfect. 19.6 will be the correct answer. So જો આમાં કાઈ નથી, ખાલી સિમ્પલ તમારે ઇક્વેશન ઓફ મોશન યુઝ કરવાનું છે. તમને ગ્રેવિટી 9.8 છે. આટલું સિમ્પલ. આમાં કેચ શું છે કે તમને 4 સેકન્ડ આપી છે. જો તમે ટાઈમ 4 સેકન્ડ લ્યો તો તમારો આન્સર 39.2 આવશે and that will be wrong answer. So આમાં you have to make sure that you understand that the total time is 4 second. એટલે 2 સેકન્ડ એને ઉપર જતા થાય ને 2 સેકન્ડ એને નીચે થતા થાય. પણ મારે તો જ્યારે ઉપર જાય છે એની સ્પીડ ગોતવાની છે. And so I should take time as 2 seconds. Is everybody clear with this?
Yes, ma'am.
So the answer is 19.
Yes, ma'am.
That in it, the final velocity is u minus g t. So v is equal to 0 and u is 19.6 meters per second. This is 2016. Now, chalo, this is 2015. I did not find 2020 ka paper. So 2015 again you have. Can somebody tell me what does it say? The height above Earth's surface at which the value of acceleration due to gravity reduces to half its value on Earth's surface. So Earth's surface ma g hoy તો મારે ક્યાં જોઈ છે કે જ્યાં નવી ગ્રેવિટી અડધી હોય, reduces to half. So G dash is G by 2. So now I've given a big hint. Tell me the answer. I am not giving you the answer. Chalo. Take some time and tell me the answer. Which formula will I use? The first thing is you should know કે કયું formula મારે use કરવાનું છે. તો above height, above Earth's surface. That means you are moving away from the surface of Earth. તો એના માટે આપણે કઈ formula કીધી? Guys, which formula will I use? G dash is equal to G into 1 minus 2h by r. હવે મારે ગોતવું છે શું? તો કે હાઈટ ગોતવી છે. રેડિયસ આપેલું છે. ગ્રેવિટી મને ખબર છે, but I don't need gravity. Don't do that donkey's work કે ગ્રેવિટી 9.8 લઈને એને ડિવાઈડ બાય 2 કરી અને 4.9 ત્યાં લ્યો અને પછી અહીંયા 9.8 લ્યો. Don't do that. આ G dash ની જગ્યાએ substitute G by 2 because my new gravity is half the original gravity. કીધું છે ને, reduces to half. So now substitute that and tell me what should H be. Chalo guys, do that much at least. This is the formula that I use. The question says gravity reduces to half its value. So G dash is G by 2, that is G into 1 minus 2h by r. Common sense says આ cancel થઈ જશે. જો તમે અડધું કરીને સબસ્ટિટ્યુટ કરો ને તો પછી કેલ્ક્યુલેશનમાં થોડું વધારે કોમ્પ્લિકેટેડ થઈ જાય. એમેય તમને આન્સર સેમ જ આવશે, પણ કેલ્ક્યુલેશનમાં થોડું કોમ્પ્લિકેશન વધી જશે. So if you don't want that, this is how you do it. So guys, now I have given you a simple equation. Tell me H શું હોવું જોઈએ કે જ્યાં ગ્રેવિટીની વેલ્યુ હાફ એટલે 9.8 ની જગ્યાએ 4.9 થઈ જાય. What's the answer, guys? And a word of advice, whenever you are sitting for a session, I know I'm not sure whether you are allowed calculators in your original exam or not, but a session is just 1 hour. So if we have to do numericals, I think you will need your calculators. So sit with your calculators whenever you have a physics session or a math session. It will be easier. Guys, I'm waiting for the answer. What is the answer? હવે ખાલી ક્રોસ મલ્ટિપ્લિકેશન કરવાનું રહ્યું, બાકી કાંઈ છે જ નહીં.
Ma'am, A.
That is absolutely correct, beta. G dash is G into 1 minus 2h by r. That is the formula that we had, that the new gravity, the gravity decreases as you move up. Similarly, the gravity decreases if you move towards the depth. So the new gravity is G into 1 minus 2h by r. Now I want height at which the gravity will become half what is on the surface of Earth. So substitute that. G and G will get cancelled. You open the bracket. You will get 4h by r is 2, or h is equal to r by 2. That is 3200 kilometers. So if you go up 3200 કિલોમીટર તમે ટ્રાવેલ કરો ફ્રોમ ધી સરફેસ ઓફ અર્થ, તમારી ગ્રેવિટી 4.9 ત્યાં હશે. Are we clear with this, everybody?
Yes, ma'am.
All right. Answers, I am expecting you to tell me the formulae. I am expecting, because the idea of the lecture is that you become self-sufficient where you can tell me answers. Chalo, now this is a JAM question. Two planets P1 and P2 having masses M1 and M2 revolve around the sun in elliptical orbits. with time periods T1 and T2 respectively. The minimum and maximum distance of planet from Sun are R and 3R, whereas for planet P2 are 2R and 4R, where R is constant. Assuming the mass is much smaller than mass of Sun, the magnitude of T2 by T1 is. Which formula will I use, children, here? Boys and girls?
That's third law.
મેમ રૂટના અંદર m1 by m2 is equal to રૂટમાં r1 by r2.
સાંભળ, m1 by m2 તો તને નેગ્લિજિબલ કીધું છે, એટલે અઝ્યુમિંગ m1 and m2 એટલે ઈ તો તારે આવશે જ નહીં. વન ઓફ ધ ગર્લ્સ સ્પોક ઇટ કરેક્ટ. કેપ્લર નો થર્ડ લો, કારણ કે તારે ટાઈમ પીરિયડ જોઈ છે ને બેટા, અને તને રેડિયસ આપ્યા છે. સો t1 સ્ક્વેર બાય t2 સ્ક્વેર, આપણે પણ અહીંયા તમારે t2 by t1 જોઈ છે. So you take t2 square by t1 square is equal to r2 by r1 cube ને cube. આખા બ્રેકેટમાં ક્યુબ કરો કે ઇન્ડિવિડ્યુઅલ, આન્સર સેમ આવશે. આ ફોર્મ્યુલા યુઝ કરવી પડે. હવે r શું યુઝ કરશો તમે? r2 ને r1 શું યુઝ કરશો? કારણ કે
આન્સર is 3/2c.
what
3/2 answer is c.
Absolutely correct. I'm so happy one person is given me the answer. Absolutely correct, beta. અહીંયા તો તમને બે આપ્યા છે ને રેડિયસ, તો તમે રેડિયસ શું લેશો? શું કરવાનું? બે રેડિયસ આપ્યા હોય તો
એવરેજ લેવાનું છે ને,
પહેલા એવરેજ લઈ લેવાનું, એટલે r plus 3r/2. તો પહેલા પ્લેનેટ નું રેડિયસ આવશે 2r અને બીજા પ્લેનેટ નું આવશે 2r plus 4r/2. So that is 6r/2 એટલે 3r, અને પછી સબસ્ટિટ્યુટ કરવાનું. Here the formula that you use is Kepler's third law. Now, which is T2 by T1 the whole square, and that is equal to R2 by R1 the whole cube. There was one question even in 2019 paper, but it was similar to અહીંયા જેમ કે ઓલો question હતો કે a ball is thrown vertically upwards. એમાં question હતો kangaroo is jumping અને find its initial speed. બાકી બે concept same હતા, અને obviously kangaroo is jumping અને એમાં ટાઈમ જુદો આપ્યો હતો. આમાં ટાઈમ 4 સેકન્ડ્સ હતો, એમાં કંઈક ટાઈમ જુદો હતો. આમાં બોલ થ્રોન અપવર્ડ્સ, ઓલામાં કાંગારૂ જમ્પિંગ અપવર્ડ્સ હતો, બટ કોન્સેપ્ટ સેમ હતો. તો ઇવન ઇન 2019 you had the question. That's what I'm saying. So every year you can see કે gravity ઉપર એક question હશે જ. So the first thing you do is take the ratios and then substitute. T2 by T1 the whole square is equal to 3r by 2r the whole cube. I hope everybody understands r and r gets cancelled. Cube of 3 is 27, cube of 2 is 8. And so I can write this as 9 into 3 upon 4 into 3. And આ બેને હું આની બારે કાઢું તો it will be 3/2, sorry 4 into 2 into root 3/2. આમાં રેશિયો તમને T2 by T1 કીધો છે. સપોઝિંગ T1 by T2 કીધું હોય તો શું આન્સર આવે? Guys, T2 by T1 કીધું હોય તો what will be the answer? Then this would be the answer. Ratio ઊંધો થઈ જાય.
આનો તો મેં ઊંધું કરે.
હા, what બેટા?
મેં મિસ કેવા જતો હતો પણ પછી કઈ વાંધો નહીં, તમે બોલી ગયા.
Yeah, બેટા. Correct. Ratio ઊંધો થઈ જાય. Now the catch in the question again, જ્યારે તમે આવા questions વાંચો, સૌથી પહેલી વસ્તુ તમને ઈ ખબર પડવી જોઈએ કે 4 ઓપ્શન આપ્યા છે. હવે આમાં લખ્યું છે assuming m1 m2 are much smaller, એટલે બાય ડિફોલ્ટ આ બે ઓપ્શન તો નીકળી ગયા, કારણ કે માસ તો કન્સિડર જ નથી કરવાના. ઇવન તમે તુક્કો મારતા હો ને તો લોજિકલ તુક્કો મારવાનો. સાવ આમ રેન્ડમલી એ અને સી બી નહીં લખી આવવાનું. આવું કરો એટલે તમારી એઝ ઇટ ઇઝ પ્રોબેબિલિટી આન્સર સાચા પડવાની વધી જાય. એટલે બાય ગિવન કે કાં તમારો આન્સર સી હોય ને કાં તમારો ડી હોય. હવે તમે વર્કઆઉટ કરો તો ઓબ્વિયસલી તમને આન્સર આવવાનો જ છે. તમે બીજું કાંઈ ના કરો અને ખાલી રેડિયસ જોઈ લ્યો ને કે ભાઈ આનું રેડિયસ 3r છે અને આનું રેડિયસ 2r છે, તો ભાઈ ડિનોમિનેટરમાં ક્યાં ઓછું છે? તો કે ડિનોમિનેટરમાં આ 2 ઓછો છે, 3 વધારે છે. તો એમે even with logic આ ઓપ્શન નીકળી જાય ને તમારે આ જ રહે. So this is like, quick acts wherein even without working you can reach to the same answer. તમારે calculate કે work કરવાની જરૂર નથી. Just use your logic because physics is mainly about logic, and if you get that correct, then I don't think that you should have an issue. All right, is everybody clear with this?
Yes, ma'am.
Right. So now we have few more practice things.
Yes, ma'am.
I think the time is up, so I don't know whether sir has already entered or sir is listening, because I have put more questions, so I can continue. Chalo, take the first one. Same formula. Which formula will I use? R's value is given to me. H is 32 kilometers is given to me. તમારે ખાલી આ જ સોલ્વ કરવાનું. G તો as it is છે. શું આન્સર આવશે ગાઈસ ફર્સ્ટમાં? Anybody? You can just note down and do it a little later. Now this is of the depth. So you have G dash is equal to G into 1 minus H by R or D by R. Depth લેવી હોય તો D લખી નાખો. G is given to you, R is given to you, depth is 100 kilometers. You substitute the value, your new gravity answer is this. Alright, so just remember the basic formula: height, depth, Kepler's motion, and એનાથી વધારે the most important તમારામાં જે મોસ્ટલી પૂછાય છે is those motion due to gravity. V is equal to U plus AT. So V is equal to U plus or minus GT. Those formulas, if you remember, you should be fine. Force of gravity is least at what place? Quickly now, this you don't need any kind of
Equator.
perfect.
Equator.
Perfect. પછી આમાં હું કઈ ફોર્મ્યુલા યુઝ કરીશ ઓર્બિટલ વેલોસિટીમાં? easiest, don't use gmm by r square, કારણ કે જો ગ્રેવિટેશનલ કોન્સ્ટન્ટ એ નથી આપ્યું, માસ એ નથી આપ્યું, ખાલી બે જ વસ્તુ આપી છે, ગ્રેવિટી અને રેડિયસ. So orbital velocity is root gr. All right, what's the answer for this fourth one, guys? Substitute and tell me. Even if one or two are doing, I'm very happy. Anybody? Answer is all right. In the last one, again, you use the formula, you use the formula T1 by T2. Here they've said new time period. ત્રણ વસ્તુ આપી છે, તમને new time period ગોતવાનું કીધું છે. So then I'll have to write individually T1 square by T2 square is equal to R1 cube by R2 cube. અને એકનું છે R તો બીજાનું 2R છે if the distance between them doubles. So this is how mostly the questions you will have. They are very easy if you know the formula. It's just a little bit of mathematical manipulation. Nothing more than that. Please make sure that you go through the whole of it. All right. Professor, I think I'm done. Anybody has any questions or anything? You're welcome, but I hope that it was something that all of you.
I think they may send the
Yes.
question. If anything required, I will convey to you. Okay.
Right, sir.
Thank you so much, ma'am. Actually, we could not introduce you because
No problem, sir.
there was less time, but still, at least I should know who is you. So, Priti ma'am, she is the Priti Dave ma'am, and she is the heading the Department of Physics in one of the very renowned school in the Rajkot. It is SN Kansagra School, and she is teaching physics since 25 years. And most important thing, she is associated with GSBTM, particularly this type of lecture since 2011. So she has a very vast experience to deliver and I think madam has justified 100% of this topic because it's so lengthy. And the way you explain and the way you touch each and every corner of all the exams, it is, ma'am, excellent. And you have really given the excellent coverage on the particular topic.
Thank you so much, sir. I just hope that the children benefit and they are able to do physics with the same passion as they do biochemistry or microbiology, and
Yes.
then
No, of course, ma'am. Actually, I would like to add one more point. Students and participants, please mind it. Any student who is good in biology, they are more or less, they can score better or they are equally a score, but only physics and chemistry, it will give you the rank. So please mind it. Either NEET exam, either MSc entrance, or either any exam where physics and chemistry is mentioned, only this part will giving you the provide the rank, proper rank. So without physics and chemistry, you cannot, achieve the good rank. Thank you so much, ma'am. Thank you.
thank you, sir.
Thank you for your excellent coverage. It was really nice lecture. Thank you.
Thank you, sir. Thank you so much.
Participant, I think we should continue the lecture from 12:50.